Okay. So now, so this is our element A. Okay. So we know that stress X is equal to 0. There's no normal stresses acting in the X direction. Okay. So now we are going to find the shear stress. Okay. So we're going to find. Yeah, I'm going to bring this down. So what we're going to find out? So we're going to find. Right. We're going to find the shear XZ. Okay. Generated. Okay, by Vx. Okay. And we're going to apply thin wall analysis. So all the beams, okay, all the beams that we're going to do, oops, you can't see now, my bad, sorry. So all the beams, right, we're all going to apply thin wall analysis. Okay, why I say apply thin wall analysis? Because we need to draw the shear flow. Okay, so here we go. So now, so we are going to look at Vx. So I'm going to copy this diagram again. I'm going to paste down here. Okay. All right. So we are now what we are going to do is we are going to look at Vx. Okay. So Vx. So if we were to draw our transformation, so this is our X and this is our Y. Okay. So we found that Vx is coming in this way. Right? Vx is coming in. So Vx is equal to 16 times 10 to the power 3 Newton. Right? That is our Vx. Right? So the formula that we're going to do now is shear xy or shear xz is equal to Vx over Iyy. Now we're going to do what? Qy divided by what? T. Okay. So what do we have? So Iyy, we know. We don't need to calculate all this now. Thank God for that. Some of you say, yeah. It's equal to 9.03 times 10 to the power minus 6 meters. Right. The thickness, this is where element A is. Okay, this is where element A is. Right. The thickness is the thickness of the what? Flange. So the thickness of the flange is what? No. 11.8 times 10 to the power 3 meters. Okay. So we know thickness is equal to 11.8 times 10 to the power 3 meters. What is always the problem? Qy. Right? Qy will also. So remember our 4 rules. Or how many rules? I forget. I'm going to copy and paste our 4 rules. Where are our 4 rules? I can't find them now. Hold on. I'm looking for something. Okay. Thought I did paste our 4 rules. Oh, yeah. Copy. And then I'll come down here. I'm like you guys. The last time I did this was the last time I taught you. I forget all. Okay. So those are our 4 rules. So how to calculate, right? How to calculate our Qy. So we have to obey the rules. So V and I are constant. We know datums, etc. Analysis will be carried out from the Y maximum. So the analysis direction will be in this direction. I'll use a different color. Sorry. So this is the analysis direction. Okay, that's the energy. But how will the shear flow flow? The shear flow will flow this way. Okay. Right, because the shear stress, the shear force is in that direction. So this is how our shear flow will flow. Okay. So this is a wide flange analysis, yes or no? Right? So we know that this is a wide flange. So we know that what we have over here is a wide flange analysis, not a closed beam, right? Or box beam analysis is a wide flange. So the analysis direction is from maximum. So this is the area that we're going to take. Okay, that's the area that we're going to take. And then we have to find this distance over here. So we have to find the distance from here, right? We have to find the distance from here to here. So this is our X bar distance. Okay, so we have to find what is our A, right? We have to find out A and what is our X bar. Okay, so the area is equal to the width. Okay, so I'm imagine the width now is 11.8 times, no, not the width. One of the dimension is 11.8 times 10 to the power minus 3. And then the area is what? 75, right? We are given 75. Right, so because the distance from here to here is 75 millimeters, right? So now we have to find the X bar. So the X bar is equals to 0.166. The 0.166, because this is the BF, right? Minus by 0.075 divided by 2. Okay. So from here, we get 0.166 divided by 2 minus 0.075 divided by 2 times by 75 power of 3 times by 1.8 power of 3. So it's equal to 40. Down here, I forget the times 10 to the power minus 3. So this will be equal to 40.2675 times 10 to the power minus 6 meter cube. Okay. So from here, you can calculate the shear XZ equal to the shear ZX, and this will be equal to the V multiplied by Q, which is equal to 40.2675 times 10 to the power minus 6 divided by I divided by T, right? So this is 16 power 3 times 40.2675, 2675 power minus 6 divided by 9.03 power minus 6 divided by 11.8 power minus 3. So this will be equal to 6.0465 times 10 to the power 6 Pascal. And because of the shear flow direction, okay, the shear stress is going to act in this direction. We have to put down the direction. Okay, so if we go back to our analysis, right? If we go back to our analysis, right? So we have just done Vx, yes or no? Right? We have just done Vx. Okay. So we have done the shear force on Vx. So the next one we are going to, is there a Vy? I think that's a Vy, right? That's a 20. So the next one is a Vy. So if you look at the Vy, right? If you look at where did we analyze the Vy? Hold on. Vx. Oh, I did not write the Vy. Oh, I did. So you look at the Vy over here, right? Vy is 25 times 10 to the power 3, right? Right? Vy is times 10. So I wrote what? The shear stress, the general trend, okay? Because we have to analyze the cross-sectional area. So if you look at, based on Vy, the 25 kilonewton, and element A is at the where? Furthest distance away from the what? From the, sorry, element A, right? Element A, right? Element A down here is the furthest distance from the neutral axis for Vy. However, the stress is not equal to what? 0. Why? Because like what I highlight down here, we have also to analyze the cross-sectional area. Okay, so let me explain what do I mean by that. Okay, so I'm going to still copy the same thing. Let me copy cheeky sort. It doesn't allow me to copy. Interesting. Copy. Okay, so we'll be doing, where are we now? Okay, so what we are going to do now is find, so we're going to find the shear xz. Okay, now is generated by Vy. Okay, generated by Vy, and then we also have to apply thin wall analysis. Right. So when we start to apply thin wall analysis, this is where the issue comes down. So now it is V in the Y direction. Okay, so we know that this is X. And this is what? This is Y. Okay. So now we know that Vy, right? So if you look at Vy is going to come down from here. This is the 25 times 10 to the power 3 Newton. And this is your what? Element A. Right? That is your element A. And because a thin wall analysis is what flange, how the shear flow will flow is flow this way now. Right? Remember, we draw all this arrow. Right? Remember? So I know, what did I say? Element A is furthest away from the neutral axis. However, based on thin wall analysis, there is still what? There is still cross-sectional area, right? There's still cross-sectional area. And now we are going to, so we have to write down our formula. So write down formula first, okay? I always write down formula. Then I know whether I'm going to use X direction or Y direction. So the shear XZ is equal to Vy over Ixx Qx, right? So means what? The first moment of area about the what? X-axis, right? Qx is the first moment of area about the what? About the x-axis. This one is the first moment of area, right? About the y-axis, right? The first moment of area about the y-axis, right? The one that is earlier, the one before. Sorry, I forget to move my. So this one, right? X bar, right? When we take X bar is the first moment of area about the what? The y-axis, right? So this one is Qx, right? So Qx is first moment of area about the x-axis. So now you have to use the what? You have to use the y direction. Okay, so now you have to use the y direction. Now I'm a bit dazed now. So y direction. So you have to use this direction now. Okay, for your first moment of area. Okay. Hey, why do I stop there? First moment of area. Wait, let me write up the formula. So Qx is equal to A y bar. Okay. So if this is my, so it's relative to my what? To my x-axis. So it's from here to here. This is my y bar. Okay. So the other one is x bar. Did I draw it correctly? This yeah, x bar. Okay, it's correct. Okay. So that is our y bar now. Okay. So now, so what do we know? We know Vy. Vy is 25 times 10 to the power 3. Ixx we know. Okay, the t is missing down here. Ixx is equal to what is our Ixx? 40.8.